And now it's my pleasure and personal honor to welcome back to our podium our honorary member, Bill Gates, to introduce today's distinguished speaker. Bill.
I'm really tickled to introduce to you today Mr. Walter Isaccson. Before Walter became president and CEO of the Aspen Institute, he was the chairman and CEO of CNN and the managing editor of Time magazine. He held these prestigious positions during a wonderful career in journalism that started after his schooling at Oxford as a Rhodes Scholar and continued to the Sunday Times of London, the New Orleans Times-Picayune, before he joined Time in 1978. At Time, he served in many roles, including political correspondent, national editor, editor of news media, and finally managing editor in 1996. Walter was born in New Orleans, and his commitment to that area has continued throughout his life, through his membership on the board of trustees at Tulane University, to appointment after Hurricane Katrina to the vice chairmanship of the Louisiana Recovery Authority. Walter's written a number of books, including biographical sketches of Benjamin Franklin and Henry Kissinger, and now his most recent about Albert Einstein, which was released just in April. He's a wonderful citizen. He's an insightful educator and a great contributor to the many causes that he cares about in this world. Please welcome Walter Isaccson.
Thank you very much. It's a great honor to be introduced by Mr. Gates and to be in front of such a wonderful place, the Rotary Club. I love being at the Rotary Clubs. I think the Kaplans, who are visitors from Alexandria, Louisiana, will attest that my grandfather, Cecil Seff of Alexandria, Louisiana, brought me to my first Rotary Club meeting down in Louisiana, and I've enjoyed them ever since, and especially the four-way test of the Rotary Club that I've kept not only to my own heart, but also in the biographies I write. It's almost a test I use, whether it's a Benjamin Franklin or an Albert Einstein. And I wanted to talk to you today briefly about Albert Einstein, why I chose to write about him, and especially about the creativity and imagination that informed his life. Because to me, one of the things you know from being here in Seattle is that there are a lot of intelligent people in the world, but if you're going to be a good Rotarian, you ask yourself, how do you go beyond being intelligent to being significant in this world? And whether it's the wisdom of a Benjamin Franklin or the creativity of an Albert Einstein, those are the type of things that make you special, not just intelligent. The good news for those of us here who are parents is that Einstein was no Einstein when he was a kid. He was very slow in learning how to talk, so slow that the family maid called him the dopey one in the family. He was also very rebellious, the type of person who always defied authority and challenged the conventional wisdom. That caused one headmaster to kick him out of school and another to amuse history by saying, "This Einstein will never amount to much." But I do think it was those two qualities, that slow verbal learning ability and that rebelliousness, because each of us learns in different ways, each of us becomes imaginative in different ways, that made Albert Einstein the special genius that he was. His slowness in learning how to talk caused him to think in pictures, and every single one of his great theoretical leaps comes from doing a thought experiment, a visual thought experiment. That's what you and I get to call daydreaming when we're not Einstein, but for him it gets to be called a thought experiment. And secondly, it caused him to marvel at things that the rest of us consider rather ordinary, rather mundane, such as when he was age 5 and his father gave him a compass, and he sat up in bed nights on end, sort of watching as the compass needle would twitch and point north, and would fascinate him. Now, you and I probably remember getting a compass when we were a kid. Go out in the woods, it points north, you say, oh, cool, wow, and then you're on to something else about 5 minutes later. But for Einstein, it was his sense of the hidden forces that underlie the universe that caused him to marvel for so long, indeed until his dying moments on his deathbed in 1955, about the nature of field theories and how they work and how they reveal the underlying spirit manifest in the laws of the universe. Being such a rebel, he's also the type who sort of gets his teachers annoyed at him. But unfortunately for history, the myth that he flunked math as a student isn't true. I was kind of hoping it would be true. If you do a search for, Einstein failed math on the internet, you get about 66,000 websites that say, as everybody knows, Einstein flunked math as a kid, so maybe there's hope for me or something. But instead of flunking math, it was once again that visual ability that served him so well. He could visualize the underlying physical reality behind equations. He knew that an equation was just the good Lord's brushstroke for painting something in physical reality. I was helping my daughter with her math homework recently, and she got one of her equations wrong. And I said to her, Betsy, look at the equation. Look at it. You should visualize it. It's got to slope upward. And she said, what do you mean? And I said, well, there's a reality behind an equation. If you're translating, because she's a Latin student, translating the Odyssey, and you see the phrase rosy-fingered dawn, what do? You picture a rosy-fingered dawn. Well, you should picture it when you see an equation. She says, oh, no, that's not how they teach math anymore. They don't teach it that way. But I think math and science should be a visual and imaginative thing. Albert Einstein, when he was 16, my daughter's age, he was actually a little bit smarter than my daughter, at least in math. And so he's looking at Maxwell's equations, those wonderful set of equations that define an electromagnetic wave, a light wave. And he's marveling at the fact that the light wave, according to the equations, always travels, no matter what your frame of reference, at a constant speed, the speed of light, 186,000 miles per second. And as a 16-year-old, he's doing one of his visual thought experiments about what would it be like to catch up with a light beam. What would it be like if you rode alongside the waves? Would the waves look stationary to you? Well, Maxwell's equations don't allow for that, and he said it caused him great anxiety, caused his hands to sweat. He was so worried about this problem, making me think of all the things that caused my palms to sweat when I was 16, which weren't Maxwell's equations. But that's why he's Einstein and I'm not. Anyway, he runs away from school like my old friend, Dr. Benjamin Franklin, runs away as a teenager. He applies to the Zurich Polytech, the second best college in Zurich, and doesn't get in. I would love to find out the name of the admissions officer. But anyway, he does get in on his second go-around, but once again that rebelliousness strikes him, so that he's able really to tick off all three of his professors, main professors there. Heinrich Weber, the physics professor, so old-fashioned he doesn't even teach Maxwell's equations, so Einstein starts calling him Herr Weber instead of Herr Professor, which Professor Weber considers an insult and quits talking to Einstein. Pernay, the lab instructor, Einstein's not very good at labs and experiments, which is why he has to become a theorist. So he ends up blowing up the equipment in Pernay's lab, and Pernay puts him on academic probation. He doesn't even go to math classes. He makes his friend Marcel Grossman take notes for him. So the math professor, Minkowski's report is that Einstein is a lazy dog. So anyway, when he finally graduates, he's the only graduate of the 1900 class of the Zurich Polytech in physics or math who cannot get an academic job. Can't get a job as an assistant professor or a teaching fellow or an associate professor. Can't even get a job teaching high school. He wanders around for 2 years unemployed until finally Marcel Grossman, the kid who took notes for him in math class, through family connections, helps him get a job as a third-class examiner in the Swiss patent office in Bern. Third class because Einstein's doctoral dissertation had been rejected twice. He didn't have a doctorate, so he couldn't be a second-class or first-class examiner. But there he is as a third-class examiner, but lest we feel sorry for him, it's that experience in the patent office, I think, that causes him his genius to come out. Once again, to think in pictures. There he is looking at the application for all sorts of devices and having to visualize the underlying physical theory behind them. And he's looking at the trains outside of his window, which run beneath the Bern clock tower, famous Bern clock tower, into the station and all the clocks on the station. And most of his devices involve, the devices that he has applications to examine, involve ways to synchronize clocks. Because Switzerland had just gone on standard time zones, and the Swiss, being rather Swiss, they're kind of obsessive. They want to make sure the clocks are all synchronized. So when it strikes 7 in Bern, it strikes 7 in Zurich. And so all these devices to synchronize clocks, he's looking at 70 different patent applications from 1902 to 1905, and they have one thing in common. They use a signal to synchronize the clocks, a signal that travels between the two clocks, that travels at the speed of light, whether it's a light signal or a radio signal or an electric signal. And as he's looking at them, he's thinking again of that experiment he does as a thought experiment as a 16-year-old, which is what happens if you catch up with a light wave? What happens if you catch up with a light signal? And one of the things that was bedeviling physicists at the time, smarter physicists than Einstein in a way, or academically smarter, was the fact that Maxwell's equations conflict with a simple principle of relativity, which is what Galileo said, which is that all frames of reference are equal, that there's, whatever your state of motion, all you can say is that you're in relative motion. You can't say, I'm at absolute rest and you're in motion. All the laws of physics apply the same, whatever your constant velocity motion is. For example, you may think you're at rest right now, and if you look outside and you see an airplane that's flying overhead, that it's moving. But in fact, we're all moving right now. We're moving 36,000 miles an hour as the Earth goes around the sun, and even faster than that as the sun goes around the galaxy. And the person on the plane could just as soon say that she's at rest and the Earth is rotating beneath her. But that conflicts with the notion that you might see the laws of Maxwell differently if you catch up with a light wave. And Einstein's still thinking about that. And he tells his friend Michel Besso, who works with him in the patent office, that he's finally given up. He can't figure this out. No big deal. So has Lorentz, Poincaré, Michelson, and Morley. They've all been stumped by this. Then one day they're taking a walk, looking at distant clocks, looking at the trains, and Einstein says, I've got it. And he makes, yet again, an imaginative leap, doing it through a thought experiment. And when he explains to Besso what it is, he said, here it is. It depends on your definition of simultaneity. What is simultaneous? Now, you and I, we don't marvel at mundane and ordinary things like simultaneous. Somebody says, what's simultaneous mean? You say, it means it happens at the same time. But for Einstein, a patent examiner, you need an operational definition. And he says, well, something happens, two things very far away happen simultaneously. One way to define it is somebody standing halfway in between them would see the light signal from both events at the exact same time. That's what you mean by simultaneous. He says, but imagine a very fast-moving long train. And suppose lightning strikes both ends of it. And suppose there's a guy on the platform exactly halfway in between, and he sees both events simultaneously. The light hits him simultaneously from both lightning strikes. Besso goes, yeah. And then he says, but imagine a woman on the train moving fast, really, really fast. It's a thought experiment. And by the time the light waves reach her, she's a little bit further forward. And she'll say the strike in front happened first. And that just means that simultaneity is relative depending on your state of motion. Now, it seems slightly complicated, but it's not all that complicated. It's a pretty simple thought experiment. And from that, he says time is relative depending on your state of motion. In fact, as you get near the speed of light, time slows down, which is why, as you try to catch up with a light wave, you never can, because time slows down for you. Now, this sort of baffles all of it. He still doesn't able to get a job. If you don't fully understand it, rest assured that the physics establishment of Europe was still scratching their heads. But he is doing this all the time as a third-class examiner in the patent office, including when Max Planck, the great theorist, comes up with a mathematical notion called Planck's constant that explains radiation. But he doesn't know what it is. He just calls it a mathematical contrivance. In that same year, that same month that Einstein's writing his special relativity paper, Einstein writes another paper saying It's because light is a particle, not just a wave. Planck's constant can be called a quanta. And so in that one period of a few weeks, he has laid the groundworks. In fact, he has set the foundations for the two great theories of modern science, quantum theory and relativity. It's a totally amazing output just from thought experiments and imagination and creativity. He's also, as I discovered by reading all of his personal letters, which have just become available, a real flesh and blood human being. At the time, he's having a fight with his wife, a woman he had met at Zurich Polytech. They had had an illegitimate daughter together, but finally were able to get married, have two sons, having a horrible divorce. Kids are being used as pawns, and you wonder about it until you say, yes, but you know, the guy is human. We all know people who go through bad experiences like that. He even can't afford a divorce, so he says to his wife, one of these days, one of those papers will win the Nobel Prize. If you give me a divorce, I will give you the money. Now, he hadn't been accepted much by the physics establishment, so it takes her a while. She's a scientist. She calculates the odds. But finally, she takes the bet. It's not until 1922 that they announce his Nobel Prize, but she gets the money and buys 3 apartment buildings in Zurich. In the meantime, Einstein is continuing to do his thought experiments. He wants to make relativity general relativity. He wants it to include accelerated motion. And so he does a simple thought experiment while still just sitting there at his desk, which is, what would it be like to be in an enclosed chamber, like an elevator, with no windows, right on the surface of the Earth? You're in a gravitational field, so what do you feel? You feel your feet being pressed to the floor. If you take something out of your pocket and you drop it, it falls at an accelerated rate. Then he says, do the thought experiment. Suppose you're in that chamber and you're deep in outer space where there's no gravity, but it's accelerating upward real fast. What do you feel? The same thing. Your feet are pressed to the floor. He thinks it through. If you take something out of your pocket and you let it go, it falls at an accelerated rate. And from that, he comes up with the simplest but most profound of all notions of 20th century science, which is that gravity and acceleration are equivalent. Everybody should have known it. Galileo at the Leaning Tower should have known, because we all know inertial mass and gravitational mass are always equal. But it takes Einstein doing a thought experiment to upend Newton's theory of gravity by saying gravity is not an attraction between two objects. It's just a curving of the fabric of space and time that does the same for gravity as it does for acceleration. A total new way, not just an incremental change in science, but a total new way of looking at the universe. Something interesting happens to him after that, which is particularly poignant to people like ourselves, mid-career, getting older, which is Einstein was the most creative, imaginative, and rebellious person in science during the first half of his career. He throws out Newton's theories of absolute space, of absolute time, and of gravity. But something happens to him in mid-1920s when he reaches the age of 50. He suddenly becomes a defender of classical physics, the defender of the old order. He resists the new young Turks who have developed his quantum theory and turned it into a quantum mechanics that has uncertainties and probabilities at its core. Einstein feels uncomfortable with that, and they say to him, you used to be the rebel. Why is it you're no longer the rebel and you're resisting all these new changes? And he says, I guess God has punished me for my contempt for authority by turning me into an authority myself. So we all have to sometimes ask, when we get to be, at the peaks of our careers, do we resist change a little bit too much? Einstein kept resisting quantum mechanics because it got rid of the uncertainties and led to probabilities. He believed in certainties. And he said, I cannot believe that God would play dice with the universe. His famous quote, over and over again, resisting quantum mechanics. At one point, Niels Bohr, who is the leader of the quantum mechanics school at the Solvay conference, gets up and says, Einstein, please quit telling God what to do. People thought that when he invoked God, it was just a figure of speech. But another interesting thing happens to him when he turns 50. He becomes more and more assertive of the fact that is not a figure of speech, that he's deeply religious. And people in secular Berlin in the 1920s are looking at this secular Jewish scientist, and assuming that he doesn't believe in God, that he's just using it as a figure of speech. So over and over again, he writes articles on science and religion and how they aren't in conflict, saying that science without religion is lame and religion without science is blind, that they can go together. And he explains his views of God, which is a more deistic God, an impersonal God. He doesn't believe, he says, some people believe that miracles are evidence of God's existence. I believe it's the absence of miracles. It's the fact that there is a harmony in the laws of nature that to me is evidence of his existence. He doesn't believe in a personal God who will intercede, but a creator whose spirit is manifest in the laws of the universe. He says we're like a small child entering a library, and we know that the books have been written, and we know they've been ordered in a certain way, and with our dim awareness, we try to perceive how that creation occurred and how that ordering occurred. And he said it's a topic too vast for our limited imaginations, but we must be humbled and awed by these ultimate questions. This often didn't please religious people one way or the other because they couldn't quite know what he was saying. There's a cardinal in Boston who says it still smacks of atheism because it's not a personal God who will intervene and make it a snow day for you if you pray to him or whatever. So Rabbi Morris Goldstein, who was the head of the Reform movement in New York at the time, sends him a telegram saying, Einstein, do you or do you not believe in God? Answer, 50 words or less. Answer, paid. He doesn't use up all the 50 words. He just says, I believe in Spinoza's God, a God whose spirit is manifest in the harmonies of the universe. And it may be hard sometimes for a cardinal or a rabbi, sounds like one of the jokes here, to understand that. But I think all of us, as we grapple with science, religion, and our faith, go through periods when we think of a deistic God and trying to figure out the mysteries of the universe that way. Throughout his life, I think he did live by the four ways of the Rotary. He always asked about what is true, what is fair, what is beneficial, and promotes goodwill. He becomes somebody who, even though he was a pacifist, is resisting Hitler, so he writes a letter to Roosevelt explaining how a chain reaction can occur based on E equals MC squared and why America has to build a bomb. He becomes very ardent American citizen and even insists that he go through the process of becoming a citizen, taking the test, leaving America for a while, for a week, to come back on a citizenship application visa, and sworn in, giving a wonderful speech called I Am an American, about the freedom and the connection between freedom and creativity, that the 20th century is all about people who fled oppression, whether it be in Germany or the Nazis or the communists, to come to places that were free and places that were more creative. And until his dying day, he is fighting for world peace. On his deathbed, after his hemorrhage, he's hemorrhaging, and in Princeton Hospital, he's refused an operation, knows he's going to die. But he signs the Bertrand Russell Albert Einstein Manifesto calling for world peace. In an atomic age, he writes a speech saying that he's speaking to the world today as an American citizen. It was a speech for Israeli Independence Day, but he makes it a larger. He just writes the first sentence of the speech. He knows he'll never deliver it, but he's starting to write the speech, saying, I speak to you today not just as an American citizen or as a Jew, but as a human being. And he wants to talk about world peace. But the pain becomes so great on that last day that he puts it aside, but a few minutes later on his last afternoon, he revives a little bit and reaches to his night table and once again starts writing. But this time, it's yet another set of equations that have occurred to him in his constant struggle to get a unified theory, a theory that will overcome the uncertainties of quantum mechanics. And so you can see that final pages he wrote himself, those final equations, one after the other, still making a few math mistakes, crossing them out, getting them on, until finally at the end, the last line kind of dribbles off as he goes to sleep for the last time. One more line that he hoped would get him and the rest of us just one step closer to the spirit manifest in the laws of the universe. So that's how a very impertinent, rebellious, but unbelievably creative and imaginative patent examiner became the mind reader of the creator of the cosmos, and the locksmith of the mysteries of the atom and the universe. Thank you all very much. Thank you.
Thank you, Walter. We have time for some questions. Danner and Larry have the microphones. If you would raise your hands. Sure.
No questions up until finally. Yes, sir.
I thought I might try one. Is it true that Einstein's brain is in a jar or something like that? And have they
When he
found-
dies at Princeton Hospital, there's an odd person doing the autopsy, a Quaker, who ends up keeping the brain and putting him in a Tupperware container. The last chapter of my book talks about this guy going around the country with Einstein's brain. The family was appalled, but they didn't know what rights they had. But I do think it's, and they study his brain, and they say, okay, these glions or neurons or whatever, but they don't really find anything too much different. And I think the point of my book is that it's not his brain, but his mind and his heart and his soul that made him the genius that he was. And I try to explore both Einstein's brain and Einstein's mind in the last chapter. Thanks. Yes,
What's
sir.
the most interesting thing you learned in researching and writing the book?
What struck me, because I had access to his papers that had been sealed until last year, the most private of the papers. And what struck me the most was that he's not some cold, aloof, absent-minded professor, as we sometimes say, but he is a passionate guy in his politics, his personal life, his love life, his dealings with his kids as they're fighting back and forth in this bitter divorce right at that moment when he's doing the general theory. And in some ways people will say, well, you know, it seems to bring him down a bit. And I don't think so. It tends to make him human. And I was awed, just as you sometimes was about Benjamin Franklin, that when you get close to these people, you realize they're not made of marble, they're made of flesh and blood. And so I try to show the connection between the personality, the private life, the political passions, as well as the scientific passions. I'm going to wander out there and sign some books as this ends, but I want to thank you so very much for having me, and I'll be out right now doing the books. Thank you.
That was great, Walt. You just nailed it.
Thank you. Well, it's not hard to nail it for the record. Thank you.
Thank you, sir. That was stimulating, illuminating, inspiring. Next week, May 9th, will be Raj Manhas Day here at Seattle Rotary. We'll be honoring Raj as he steps down from his post as Superintendent of Seattle Public Schools. Our guest speaker will be John Medina, talking about early childhood education. And we will also be treated to one of the concerto winners from the Seattle Young Artist Music Festival, a wonderful young violinist. Which brings us to this week's Pretty Good Rule. This is a really good one because it's really short. Share credit, shoulder blame. See you next week. We are adjourned.
Seattle Rotary Online is made possible in part by a grant from Enterprise Seattle. For over 35 years, Enterprise Seattle has provided client-based economic development services to businesses throughout King County and its 39 cities. More information on Enterprise Seattle and how they help businesses grow and prosper can be found at www.enterpriseseattle.org. And by First Choice Health, working with the Washington Health Information Collaborative to use technology to bring better health care to patients throughout the Pacific Northwest. First Choice Health.